Somewhere in the warm dark of a Central American rainforest, there is a leaf hanging over a stream that never stops moving. Turn that leaf over and you might find a little body resting quietly against the green, no larger than the length of your thumbnail. Look closely at its underside and you are looking straight through it. You can see the heart beating behind a window of skin, the pale loops of the gut, and the entire machinery of a living animal laid entirely bare. We have long known these frogs are see-through, but seeing through an animal and understanding how it functions are two different things. A creature with a beating heart requires blood in its veins, and blood is the specific element that makes hiding like this physically difficult. Think about what blood requires to do its job. Red blood cells carry oxygen tightly packed inside a molecule called hemoglobin. Hemoglobin is highly reactive to green light. It drinks it in, and then it throws back a deep, unmistakable red. In a forest where almost every surface reflects green, a body full of red blood glows. To a hunting bird or a wasp scanning the leaves, a normal circulatory system looks like a map drawn in fire. A few animals avoid this by simply giving up hemoglobin entirely. The icefish of the Antarctic and the larvae of certain eels run on blood as clear as water, having struck a permanent evolutionary bargain millions of years ago. The glass frog takes a different path. It keeps its rich red blood intact. Then, on a daily schedule, it performs an extraordinary act of biological plumbing, carrying its blood while completely hiding it from view. For years, proving how it manages this was out of reach, protected by a perfect defense. The moment a researcher reaches out to touch a sleeping glass frog, it wakes up and its blood rushes back into its veins. The frog turns solid, and the evidence vanishes. To catch the animal in the act, the scientists needed a new method to see inside a living, untouched, sleeping frog without laying a single finger on it. That capability arrived in 2022 when a multi-university team turned an instrument called photoacoustic microscopy onto the sleeping amphibian. The technique relies on sending a safe pulse of laser light into the tissue. The red blood cells absorb that light, generate a tiny burst of heat, swell, and emit a faint ultrasonic sound. Because researchers could not reliably look for the blood without waking the animal, they built a machine to listen for it instead. When they finally listened, the data revealed an astonishing vanishing act. As the frog rests, it drains 89% of red blood cells from its limbs, pooling them into the liver. To hold this cargo, the liver's stretchable sinuses expand. Over an hour, the organ swells by 40%, acting as a biological vault. Inside that vault, the glowing red mass is hidden by a lining of guanine crystals. It is the exact same highly reflective material that silvers fish scales, functioning as an internal mirror that bounces telltale light away. This elaborate internal engineering specifically targets the visual processing of predators. When a hunting bird scans a leaf, it is looking for the distinct hard outline and shadow cast by a solid body. By tucking its translucent legs close, the glass frog creates a visual effect called edge diffusion. The ambient green of the leaf glows directly through its limbs, softening its silhouette and seamlessly blending its brightness into the background. The shape the predator is hunting for disappears. The frog does not achieve perfect invisibility, but it forces a split second of hesitation in the hunting bird's brain, buying the exact margin of time it needs to survive. This extreme concealment exacts a heavy physiological toll. By removing the vast majority of its blood from circulation, the frog cuts the oxygen reaching its tissues by a third, forcing it into a highly vulnerable state of absolute stillness. But the deepest mystery is how it survives the process at all. In nearly any other animal, when red blood cells pool together and stop moving, they lock shoulder to shoulder into a fatal mass. They clot. Every single day, the glass frog packs its liver to bursting with motionless blood, yet it wakes up unharmed, suffering no tissue damage and no strokes, reversing the flow as if nothing happened. That specific ability reaches far beyond the rainforest. Safely concentrating and holding blood in one place without triggering a clotting cascade is a clinical priority that human medicine currently cannot replicate. Every time doctors take blood out of a human body to run it through a machine, whether during dialysis or major surgery, they fight the constant danger of the blood solidifying. The glass frog has managed a process that remains elusive in hospital settings, maintaining a static, dense concentration of blood without the trigger that leads to fatal complications. But long before we put that biology under a microscope, this survival mechanism serves a quiet, immediate purpose back on the leaves overhanging the streams. After a female lays her eggs on the underside of a leaf, she departs. The transparent father stays behind in the dark, standing guard over the glassy clutch to fend off predators. When the tropical night air threatens to dry the clutch out, the father presses his own body against the eggs, transferring moisture he carried up from the stream below, keeping them alive until they hatch. It is a quiet existence for a creature smaller than your thumb, yet it survives by consistently bypassing the standard constraints of animal biology. There is so much more of this planet left to wander. Tell us down in the comments which creature you want us to follow next, or which corner of the wild you are curious about. Subscribe, and let's keep exploring this untamed Earth together.